Alrighty, hi everybody. Welcome to the MEF2C cast. Our guest today is Kristina Johnson, is a professor at Northeastern University working on the ROSCO project, which stands for Rapid Online Sample of Communication. And more importantly, she is mom to Felix, who is what, 13-ish,
He's
right?
14 now,
14?
actually. Yeah.
And has MCHS. So, how are you today, Christina?
I'm great. How are you?
Good. I'm good. Thanks for asking. So, can you just start by telling us a little bit about yourself and your family?
Yeah. Where should I begin? How much do you want to know? My husband and I are both faculty out here in Boston, Massachusetts. We have two kids. Our oldest is Felix. And like you said, he has MEF2C haploinsufficiency syndrome, and he was diagnosed when he was 9 months old. So we've kind of been with this for a while. When he was diagnosed, there were 7 known cases worldwide. So at least, that was in the literature. The Facebook group didn't exist. Though it wasn't even called MEF2C at that point. It was 5q14.3 microdeletion syndrome. So it's been a long journey for us. And then we have another child, Bela, who is now 9. And they keep us busy. we're out here. I'm a professor of both electrical and computer engineering at Northeastern University, as well as communication sciences and disorders. So I actually have appointments in the College of Engineering, as well as the College of Health Sciences. And then I actually have an appointment at Yale University, as well as MIT and Boston Children's Hospital, just because my work kind of requires this multidisciplinary collaboration across different domains. And that's what's really fun about it to me, but also maybe a little bit different than usual, and it keeps us all on our toes.
Yeah, that's awesome. I've done my research. Your husband is also a very accomplished astrophysicist as well, correct? Yeah.
Yep. He's
Yeah, so that's
amazing.
awesome. Family of scientists. Um, I was an electrical engineering major for a semester, and it was just like it scrambled my brain.
For a
Um,
semester.
yeah.
Full stop.
Yep.
No, it's an exciting field, and I originally come from physics, so it's
Yeah.
again, we're kind of all over the block here, but it's what we like. It's what I like, at least, and it really makes every day exciting.
Yeah, that's awesome. So I guess we'll just kind of get into Felix's story, however you want to start that, kind of leading up to his diagnosis and then sort of where you went from there and sort of to what his life sort of looks like today.
Sure. Yeah. So, I mean,
Mhm.
it's, I think, important to understand from at least my part of the story is that I um, have always loved and been fascinated by like human development, child development, psychology. It's never been a field of mine until much later in my life. Like I said, I was a physics major. I minored in math and astronomy in undergrad and went straight into a PhD program to do physics for the rest of my life. But I always kind of pursued this. I have a sister who's 10 years younger than me. I was a babysitter galore as a child. I taught a third grade class my senior year of high school. So I was really invested and interested in child development. So early on in Felix's birth, he was also our first child. We were very young, at least in modern day sense. So very early in his development, I was kind of aware that something wasn't what we expected.
Sorry, when you say early in his development, you don't mean like in utero, right? You mean like
No,
okay. Yes.
I mean, like 2 months old.
Yeah.
Like I brought
Yeah.
my concerns up with the pediatrician. And I was like, he's like not looking at me, and he's like kind of always, staring to the left. And we started just even at that point. I was making little like I take a paper plate and I draw like a black spiral with a Sharpie to just try
Mhm.
to draw his attention in other directions and spin it slowly because that seemed to engage him. And like again, very early on, there were also a couple other things, like looking back, that were surprises to us. So Felix was much smaller than we expected, which we know now is relatively common in MEF2C. He also had a really hard time latching, which was part him and part me, and a number of other factors. But he was just really um, really struggled in ways that we weren't expecting, but that's not that uncommon. There's a distribution of
Mhm.
how children, arrive, and this is well within normal, just a little surprising. But looking back, we recognize that those are some characteristics that other MEF2C kids share. But like I said, developmentally, it was aware to me early on that something was going on. No one else, though. Like my pediatrician was like, you're worrying too much. Even my husband, everyone in my life was like, no, 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 this is all in your head, which was really stressful and really, really tough as a parent to go through. And I think everybody has their own experience in this kind of diagnostic odyssey that we go through, this process of finding out what's going on and the journey. both practically and mentally and emotionally and things like that. And for me, it was a lot. It was by myself. It was very isolating where I was like, oh my gosh, maybe it is in my head, but also he's not using his hands. As he developed later, every month it was like, well, I was looking for these
Yeah.
milestones and they weren't there.
That's
And
a very common thing that we've heard from mothers in particular is I knew something was wrong, and other people believe me to varying degrees, but their intuition was on it pretty early.
yeah, yeah. And I totally, and like to me, I didn't even think it was like wrong is not usually the words I use. It's just
Right.
unexpected, right? Like
Mhm.
it was not what I was expecting.
Mhm.
And so we actually made an agreement between my husband and I that if he wasn't rolling over, if he wasn't doing some of these milestones that we were expecting, like at 6 months, I was like, look, here's the CDC checklist of what he should be doing at 6 months, and he's not doing any of them. And so it was like, okay, we'll wait until 8 months, and if he's still not doing any of those, then we can call again and raise another flag. And so we did. On his 8-month birthday, I called the pediatrician, and the pediatrician said, okay, like that. Yep, yeah, I agree. That sounds, unexpected, abnormal. But I don't know what's going on. So why don't you go see a neurologist? And the neurologist looked at him and he did some reflex testing and things like that, which Felix, did not perform in the way expected, but nothing else was a flag. And importantly, in this is the case for a lot of MEF2C kids, but not all. He didn't have any like obvious features in his physical development. Like he was low tone and not meeting milestones, not rolling over, not sitting up really well, or like using his hands, all those things. But like his facial features, his hands, his feet, his body all looked as expected. And those are often flags that doctors use and have like prior to genetic testing. That was a major factor in how they looked for these types of neurodevelopmental disorders. And so the absence of those almost implies to many older doctors, especially the absence of something going on, right?
Mhm.
Until these developmental flags kind of come up. And that was our case where we were kind of being dismissed in part because he, kind of looked normal, if you will. Anyhow, at 8 months, both the pediatrician and the neurologist said they didn't know. We got really lucky in the sense that the neurologist was like, well, how about we run some genetic testing? And this was early 2012. So this was pretty radical that he considered it this early on in the process. And
Mhm.
in addition, we got another sweep of luck, if you will, like that MEF2C was included in that microarray that was done. So microarray is just like a panel. They're only looking like it's like a bunch of searchlights, a bunch of little, sorry, not searchlights, spotlights. It's a bunch of spotlights that say, we're going to look at this gene and we're going to look at this gene and we're going to look at this gene. And they don't look anywhere else. So many people, right, who in the past have had a microarray done and later find out that there's a genetic diagnosis, they just didn't look at that spot, right? If you don't look there, you don't find it. Now, a lot of people are using whole exome sequencing or whole genome sequencing. We're catching a lot more because we're looking like the bookcase behind me, like we're looking across all of the
Mhm.
pages of all of the books. But the microarray is looking, one page in one book. And if you don't look at that one for a missing word, you don't see it. So we got lucky in the sense that MEF2C was included in that. And again, at that time, MEF2C was implicated as the sort of gene of interest in this kind of 5q14.3 region, but it wasn't confirmed. It wasn't, we weren't positive that was the case. So we got a little 2-page report when he was about 9 months old that said, hey, look, he's missing this. He actually has another deletion that he shares with my husband, we later found out. So he had two microdeletions, but we were pretty sure, based on the literature as was known at that time, that this kind of 5q14.3 microdeletion was the etiology or the cause, an underlying mechanism behind the delays that we were seeing. And for me, that moment of receiving it, my husband went to the appointment by himself. I was back home with my family in Indiana for a funeral, an unexpected funeral of my best friend's father. And I brought Felix with me, and I remember the call very, very well. And to me, it was like, okay, let's go. Like
Mhm.
I was like, this is where I need to be. It was clear that then I wasn't like at that moment, kind of, I wasn't going back to physics grad school. I was, like this was where I was going to pour my time and energy and effort. And I know every parent goes through their own journey and their own response to this information. And this is absolutely not universal. But I do think that feeling of like, I'm going to take whatever I can and do whatever I can for this child is quite common. at some point in the process, and maybe not immediately like on the phone call, but here you are, you've launched a podcast, right? Like we've got several families who have launched, new clinical trials and large family foundations and groups of support. And, we were all sort of pouring ourselves into this. And I would say that my process, my experience mirrors a lot of other parents and families, not just in F2C. Right now, I've seen it now because of my career. I see it across genetic disorders in parent groups and families that this is it's a really impactful motivator for life. So yeah, so I sort of decided that I was going to focus on Felix, but I didn't even know what that meant at that point. I just poured all of I knew how to research. I knew how to read scientific papers. I knew how to learn things, I guess, I knew how
Yeah.
science worked, right?
Mhm.
Even though I didn't know much about this field specifically. So I just kind of poured myself into it. So I was with Felix every minute he was awake. And then in the evenings, I was actually editing scientific papers as like a way to pay some bills.
Mhm.
My husband was still in grad school at that time. We were finishing his PhD. And then I just read everything I could find on PubMed of, genetics and neuroscience and autism. I actually already had spent some time studying autism, in part for my own fascination and in part just like this kind of path of development. I was very aware of it. I was like, had read several books on it, like it was a thing that I knew about, but I didn't know about it kind of from the scientific domain. And that is a little bit different from the casual perusal domain into
Yeah.
reading, like what is the literature, what is the known, um, uh, the state of the art
Mhm.
in these fields. So that became what I did. And then we came out to Boston. So we were actually in California at that time. We came out to Boston when my husband followed his postdoc out here, which is the thing you do after you finish your PhD. You do often a couple of years in a new lab, learning new skills and
Mhm.
preparing for a long career in academics. And while I was out here, Felix started preschool through a specialized program when he was 3. And that was the very first time when he was like the first time he was out of the house and in a place that I felt like he was really being taken care of and really, thriving and flourishing. That was the first time I considered at all like that I wanted to finish a PhD, that I wanted to go back into academia, those sorts of things. I was still adjacent to it, doing the editing, and I was um, working for universities at this point, doing grants editing and things like
Mhm.
that. And I was teaching college astronomy in the evenings. I was a lot of strange things. And so I was really lucky at that point to learn about the MIT Media Lab, which is a department at MIT, Massachusetts Institute of Technology, where they really welcome people from different disciplines. Remember, everything on paper is that I was a physicist who had
Right.
studied superfluid helium and like plasma physics in undergrad. And, I was interested in astronomy as a main topic. So none of it had to do anything with autism or human development, but that's where I wanted to head. And so I was really lucky to get a position there to do my PhD at MIT and did that.
Yeah. Not
Had
to
another child in that process. Oh, go ahead.
not to interrupt you, but, like,
No,
so
it's a long story.
one thing that I've found really interesting in my experience with engineers and physicists and things along that lines, essentially, like engineering in particular, essentially you're studying systems, whether that's a hardware system, a physical system, a chemical system, a software system. And like engineers and physicists have this ability to like look at a problem and just somehow wrap their hands around it and get started with it. And I think that's really valuable no matter what problem that it is that you're trying to attack. So I think, that's a really valuable tool to have.
Thanks.
So sorry, I'm gonna back up a little bit.
Fine.
When you got your diagnosis, what did they I mean, you said that was really early on, so they just said, "He's got this thing that we don't really know anything about." Was that or
Oh, I can pull it up. I could actually pull up the report because it basically says, it has these patterns of behavior. I think it'll be more interesting if I pull up the actual wording. I haven't looked at it in a while. Gotta make it available offline. Here we go. Genetics 1 of 3. Okay. De novo deletions and other loss of function mutations of MEF2C have been demonstrated in patients with intellectual disability with stereotypic movements, epilepsy, cerebral malformations. Sorry, cerebral malformation. No. Let me read this again so you have a clean copy. De novo deletions and other loss of function mutations of MEF2C have been demonstrated in patients with intellectual disability with stereotypic movements, epilepsy, and cerebral malformations. Next page. In addition, no, okay. Blah, 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 blah. Don't know this one. That was pretty much it.
Mm.
And then the other one, like I'm reading the rest. Sorry. Then it gave two papers, Lemure and Navarra, both from the previous, well, almost previous year, 2010, 2011. And so it was through those papers that I got a little bit more information. And then honestly, through a group in the United Kingdom called Unique, that had put together a pamphlet. It was like, I mean, I did what every parent does. I went straight to Google.
Yeah.
I Googled the heck out of what was known, which was not a lot.
Mhm.
There just was not much information anywhere. So I found everything I could. And it was actually the pamphlet out of Unique that gave me the most insight into it. I think they had 8 kids listed there. One of the most insightful things that I learned at that point, again, Felix was 9 months old and he had no teeth yet, right? He hadn't gone through teething. And every time he would get fussy or not sleep very well, we were like, well, maybe he's teething.
Mhm.
And it was in this pamphlet where they said, oh, a lot of these kids have delayed eruption of teeth.
Hmm.
And I was like, huh, okay, so maybe I should just stop waiting for this to happen. And that process, actually, that one experience about the teeth was an experience that I found myself repeating over and over again. And I discovered through that experience how valuable it was to understand developmental trajectories, right? It's not just a side quest. It's not just a, fanciful, oh, we kind of want to know because we're curious. It's because we as a society, as a species, we've built a lot of our infrastructure, a lot of our energy, a lot of our attention around what do we expect to happen and when. Like
Mhm.
the classes that you go to, the things that are available for people are like, okay, well, we expect a bunch of 6-month-olds to be sitting up. And this is how, we expect 2-year-olds to be running around the room. So we'll set up the infrastructure to support 2-year-olds running around the room. We expect 14-year-olds to sit in their seat and write essays about US history, right?
Mm.
It's this expectation that we have really built into every part of society. And so honestly, the teeth thing was every person I talked to, like when he's fussy or he's not sleeping, they said, well, maybe he's teething. And it was this process of realizing also, it looks like a lot of teeth don't come in until later. Maybe I should look for other causes, other
Mhm.
reasons, right? Like other things that might be going on. And in fact, he didn't get his first tooth until he was 14 months old. And I think that's right. I should go back and
Mhm.
double check, but it was very delayed. Uh, it was a realization of okay, we're on our own path here, but maybe not also our own path. We're on a different path. We're on a path where we need to learn and understand the trajectory of this path because everything else depends on it. The societal supports, the way you're going to be treated, the infrastructure and access to resources that exist, the understanding and awareness of every other person on the planet who's used to looking at, a 9-month-old and expecting X or a 14-year-old and expecting Y. That is all built into this kind of statistical model, this thing we have in our head, these expectations of what we do at these different ages. So again, the teeth is kind of a trivial one, right? It didn't impact our life that much,
Mhm.
but it's an example of the type of research that I do now that's really looking to understand and map these developmental trajectories of individuals who are, way outside our sort of normative basis of existence. Like way outside the norm is a easier way of saying that.
Right, yeah. Yeah, I was curious about your diagnosis because it seems like lucky isn't the right word, but your experience with the diagnosis sounds like it was almost better than a lot of people's because they didn't have as much information yet. Like the more common story we hear from kids who are, say, 5 and younger's parents are like, my geneticist said my child will probably never walk, will probably never talk, will probably never live on their own, will probably never do all these things because we have a very limited amount of data on this. And what data we do have kind of indicates that because as you're trying to change, our tools are very crude. And those are the things that are easy to measure and sort of easy to start with.
I should clarify, we were told all those things
Yes.
too, right?
Gotcha.
So, we were absolutely told, this is a long-term thing. He will likely never talk. He will likely never walk. He will likely have epilepsy. He will likely have autism, all these things. I wasn't there for the, the meeting
Yes.
with the neurologist. And I'm I'm a scientist, right? So, like, for me, it was one thing to hear it from one person. It was
Mhm.
another for me to start building up my own knowledge deck,
Yes.
right? So,
No, yeah.
I almost always, when I hear a piece of information, I take it in as one piece of information. And
Mhm.
until I can validate it with other pieces of information or my own research or my own studies, then it just kind of lives as that one piece. Like, I try very hard not to generalize something that I've only found one place, or I've heard in many places, but like this the same story or something suspect about it, right? Like, I'm constantly, I
Yes.
don't know, like you said, a physicist in here or whatever, like I'm constantly building these models in my head.
Mhm.
So yeah, we heard the same thing too. And I, again, it was a long time ago, so I'm pretty biased in these memories. I'm sure they're not
Mhm.
exactly correct. But you're right, I didn't have enough other, well, I don't know if it goes the other way because there's lots of kids in MEF2C now that are walking, and some that have words, and some that,
Yes.
like all these
Right.
things. So, like, I don't know which way it would go if I had more information from MEF2C, whether my expectations would have been different. I think they're about what they are now. Sorry, I'm really
No, that's
analyzing this
okay.
in real time right now.
See, for me, sorry,
It's okay.
like, and I'm not obviously a scientist of anywhere near your caliber, but I have an undergrad degree in essentially wildlife biology. So I understand kind of the basics of how this stuff worked. And when they said, yeah, he's got this thing and there's whatever, I think there's between 400 or 500 cases as documented by the Facebook group, like my brain instantly went, well, you can't put too much stock into anything that they're going to say about this because there isn't enough data available right now to make any like reliable conclusions about anything. So that just understanding what I understand about that kind of allowed me to not dismiss, but not put too much stock into anything negative or positive that they said because I understood that a lot of understanding things is knowing what you don't know, and I at least had an understanding of how limited the information that existed was.
I think that's a beautiful way of putting it, and I think I'm in a similar boat, right? I think
Mhm.
I took a similar approach of like, okay, well, here's some information. We clearly don't know a lot, and that means it's up to me to go figure out what we can and do know.
Mhm.
And so that was like just started a research rabbit hole, but it didn't fix expectations for my son. It did change them, right? So like I knew that the expectation is that he wouldn't talk ever absent
Mhm.
speech, and I found that very quickly in the paper. So like the genetic report that I read to you, those are not the memories that I have of these original processes. I have memories of finding papers that say not walking, and even
Mhm.
the unique thing, no talking, absent speech, autism, epilepsy, stereotypies, like low muscle tone, different eye contact, delayed teeth eruption, and
Yeah.
those sorts of things. Some musculoskeletal things. I think that was about it. Those were the things that I knew. So I just maybe updated. Okay, there's a chance,
Mhm.
potentially a high chance, that these are going to be his future too.
Yeah.
But I I don't know. Yeah,
Y you also have to consider the bias, and this is just occurring to me as I'm talking. I don't know what category of whatever bias this would fall into, but MEF2C is wildly underdiagnosed, and the
mm,
people who are getting diagnosed are probably the people with the most severe symptoms.
sometimes, right? So we have to look at often ages as affecting
Mhm.
this. Younger children who are getting picked up in developmental screeners
Mhm.
are given more access now, like I said, to whole exome sequencing and whole genome sequencing, which is going to pick up on a MF2C variant or deletion. And so that I think is happening at a higher frequency. And that is almost severity agnostic, right? So as long as you're being picked up from these screeners and you are often maybe in a maybe more location specific, like access to a larger medical center, or
Mhm.
people who are more commonly running genetic screenings, you're going to get picked up. Now, the older population,
Right.
so kids where they've lived with a certain diagnosis of
Mhm.
some kind for a while. So this could be an autism diagnosis. This could
Right.
often be like an abnormal Rett syndrome diagnosis, or
Mhm.
like some of these other large umbrella buckets that we used to put kids who were not developing in the way that we expected in, because we didn't have better words for them or more descriptive words, right? It's not necessarily that some of these words are even wrong, especially in the case of autism, but it's that we didn't have a way of kind of probing more precisely as to what the mechanism, this etiology, this kind of underlying cause was. And so those are the kids where you really have to have a proactive parent, caregiver, guardian, or a really proactive doctor who's saying, "Hey, look, now we have this new tools and these new tools and technology. Let's go ahead and run a genetic screen and see if there's something happening here." And it's
Right.
especially tricky because if they maybe had a genetic screen, like I mentioned before, right? They
Mhm.
maybe had a microarray or they did something in the past and it came up negative. And if haven't been told or are unaware of what that screen really is, you may think, okay, there's nothing genetic going on. There's nothing genetically unexpected with my child. And
Right.
so you won't try it again, right?
Right.
So you kind of have to have some proactivity from either the parent or a representative of the individual or the doctor to go
Right.
back and do it again.
Yeah.
And like you said, that often happens with more severe cases, again, for lack of a better word,
Mhm.
kids where like you're still showing up to the doctor, you're still going and looking for answers, you're still asking these questions because it's a lot of work, right? There you have to get something through insurance, you have to justify
Yes.
the medical need.
Mm.
Even for Felix, we got rejected from insurance. It was a
Mm.
multi-year battle for them to show to pay for the genetic testing. And we were like, they found something. They're like, oh, it wasn't medically necessary. I don't know what version of medically necessary
Yeah.
wouldn't be needed to cover
Mhm.
something that found a genetic abnormality. But yeah, it's a process.
Yeah,
I
well, and that bias I was talking about would specifically be more towards older people, but the older people are the people from whom we would get those long-term outcomes, right? Like the people who, walk and speech. Like we talked to a family a couple weeks ago whose daughter just started speaking within the last few years and she's like 19.
Oh, that's
And
amazing.
if you think about maybe an older person who's maybe 20 now, who, they just got a profound autism diagnosis and maybe for whatever reason don't have they don't live near somewhere where they can access testing, just don't have anyone to advocate for them for whatever reason. I feel like a lot of those people could slip through the cracks, and whereas in the older population, what am I trying to say here? Those people could slip through the cracks and maybe have less quote unquote severe symptoms than some of the people who are older and have been diagnosed. Does that make sense?
Absolutely. And
Yeah.
you're absolutely like correct in this.
Mhm.
There is a bias. It's called the
Mhm.
selectivity bias. Often in
Gotcha.
our literature, like if you're
Mhm.
looking at ages, if you say, I'm going to look at a developmental characteristic, something they're doing when they're walking, when they're talking, when they're whatever. And we're going to just say, let's map all the ages of all the people that we have and track them. You'll often get a nonlinear curve. Like it won't just kind of steadily go up. You might
Mhm.
have this kind of inverted U shape, in fact, where it kind of like seems to go down, or we get a change in slope, right? Like the angle, the trajectory that they're taking. And so we kind of know that this is a bias that we have right now in the way that we sample. Now, the way around that is to longitudinally track the same people as they grow over
Right. Yeah.
time, and we'll overcome that, which is
Right.
why these longitudinal studies are really important for our
Mhm.
science. But we start with what we have, right?
Right.
So
Yeah. Absolutely.
you're gonna look, and yes, I would love, like I'm grateful for the people in the Facebook group and
Mhm.
people in just genetic disorders more broadly who are older than we are, and I
Mhm.
look to them and see like what does their life look like and how do they manage it and what decisions have they made and how are their kids doing and how are they doing. I absolutely see every person as a role model or a guiding light for this process. Scientifically, it's used a little bit differently because we
Right.
know there is that selection bias, and it's going to evolve, as it's already evolving as
Mhm.
genetic testing has become more prevalent. There are major national pushes for genetic testing, expansive genetic testing at birth, or like optional opportunities for all individuals. This is complicated ethically, politically, all sorts of things. But also in profound autism, like you mentioned, in certain autistic cohorts where we're saying, okay, hey, look, you qualify. You qualify to do a whole exome sequencing and or whole genome sequencing and to look at this more broadly because we do think that there might be an underpinning. And also I would say autism is not alone. Cerebral palsy is another one. Epilepsy, like you mentioned,
Mhm.
like you're coming in and we've got kids having seizures that look developmentally like neurotypical, except the fact that they're having seizures. And we're like, huh, okay, but like, what if we went ahead and looked at the genetics of this
Right.
and we find a much higher fraction so far in a lot of these studies. Again, not all of them, but I
Mhm.
know in cerebral palsy, some of my colleagues have spearheaded this, where we're finding genetic underpinnings in
Mhm.
places that we thought there weren't that. We thought we knew the cause of cerebral palsy was, lack of exposure to oxygen, around
Mhm.
birth or, prior to birth. But maybe there's other reasons for that. Same in SIDS, right? You're seeing this in sudden infant death syndrome, other things like that, where we have kind of given it different causes or said we don't know, right? And now we're saying, we have another variable we could look at, and that is the genetic etiology.
Yeah, I mean, think about, like, before they understood what germs were.
Right.
People don't realize that. I think this would have been, like, like, the late 1800s, I believe, I could be wrong, but, like, it used to be, like, a badge of honor for surgeons to have, like, the grodiest, uh, surgery room possible because that, like, showed how hard they were working, and then when we understood what germs were, we realized that we were spreading tremendous amounts of infection, and now that seems so elementary to you or I. And there are things that could appear similarly in genetics that 100 years from now we could be like, "Oh, yeah, of course." You know what I mean?
Yeah.
So, but go ahead, sorry.
No, I was just gonna say absolutely, right? There's so many examples of this across history, the
Yeah.
tuberculosis and,
Mhm.
just our general view of medicine overall. And I will also say we don't know everything about it, genetics yet,
Oh, no.
right? There are a lot of things we're finding. I'm sure even in this community, there are variants of unknown significance and or VUSs, VUSs, where we don't know what it means.
Mhm.
Like I told you, Felix has 2 deletions, one of which he shares with my husband, who has his own complex medical history, but is also an astrophysicist at Harvard. So
Mhm.
it's, like a thing, right? It's a thing that is complex to parse, and it's kind of the beauty of science. We get to pursue these areas of discovery,
Yeah.
but it's not as cut and dry as, we would ever think. As like I'm sure your background was really helpful in this type of questioning as well.
Yeah, I mean, there's I'm not gonna say the number because 'cause I'll get it wrong, I can't remember, but there's at least billions of base pairs, and we only sequenced them around, like, the year 2000, and even that was relatively low resolution, and I think there's been a higher resolution than model that's come out within the last, like, since 2020-ish. So, like, we're really in the infancy of genetics, which is good from our standpoint because that means that there's, like, you wouldn't wanna have an issue in a field that's been studied for, 1,000 years because a lot of people have had the issues that are left are relatively complicated. So, not that genetics isn't complicated, but there's a lot to be uncovered. So, but we're we just
Sorry.
went on a big
This
tangent
is
there.
what I
No,
told you.
I
This
started it.
always
That's okay.
happens. Sorry.
Felix and preschool is where you were at before we went on
Right.
this escapade.
So yeah, with Felix in preschool, I considered going back to finish my PhD, but at this point, I didn't want to do it in physics anymore. I wanted to do it in something related to Felix, but I didn't know what that was. So again, I was really lucky to go to MIT and be able to explore across engineering and neuroscience, and then towards the end, a lot of different communication sciences. And I was really focused on autism the entire time, but it became much more prominent after COVID hit and a lot of my neuroscience studies shut down. And I was able to continue with many of my studies, in one in particular, um, that focused on communication in individuals with neurodevelopmental differences, as well as autism, but kind of more broadly opening up that diagnostic category. You can skip all of it. Then I pursued, again, this postdoc, which is this a couple of years after you get your PhD. You often do training or a fellowship of some kind to do additional work. We're just like lifelong students and nerds.
Mhm.
And that was at Boston Children's Hospital, where I was in the Translational Neuroscience Center there, the Rosman Stone Zander Translational Neuroscience Center. And I was working with longitudinal clinical trials, so longitudinal natural history studies of 3 different genetic disorders: tuberous sclerosis complex, TSC, P10 hamartoma tuber syndrome, and Phelan-McDermott syndrome. Or PMS. And I was able to analyze data across these different disorders. And again, this was all during COVID. So I was doing a lot of like remote analysis and remote, not data collection at that point, but I did start data collection midway through. Sorry, I was doing a lot of remote analysis. And one of the things that was really apparent in measuring or analyzing this data was that for individuals who were, again, for lack of a better term, profoundly affected, right? So really early in their developmental milestones, the assessments, the measures that we had, we're not catching their change over time. And I knew this, right? I knew cognitively, I'd taken the test. I'd been on the other side of these studies. I knew Felix had tried many studies. I'm a scientist, for heaven's sakes. Like, yes, I say to science, and yes, I say to studies. And we routinely either couldn't finish them, or they were miserable experiences for us, or I knew they weren't going to learn anything from them because I was just answering no to everything. So it was really a defeating and demoralizing experience. And so I knew this from the other side. And then to be able to see, at this point, this was data that had many years. I want to be careful because some of this isn't published, but data that had, many years, hundreds of participants, a lot of firepower behind it, on a lot of funding. And we were finding things. It was really useful and informative. But for the individuals like Felix's, the MEF2Cs of the world, and this is really common, especially in Phelan-McDermid syndrome, a lot of the characteristics of PMS are similar to MEF2C, and we didn't have measures that were sensitive to their growth over time. So we were seeing flat lines or even like downward slopes and things like it was frustrating. And so this lit or relit a fire in me to want to understand these developmental trajectories, as I said before, but understand then, I knew then that I needed to go develop new protocols. And these are different skill sets. These usually do not overlap. The people analyzing things or building the devices or things like that are not typically the people developing the protocol. So I recognize that I'm coming to this as an outsider, and I was really, really lucky to have a lot of mentorship and a lot of, be able to collaborate with a lot of people in the Boston area and a lot of mentors at Boston Children's Hospital and elsewhere, to start creating new ways of measuring and even just accessing the population of complex neurodevelopmental disorders, especially those with minimal to no spoken speech. And that became a big part of what I do. So in 2023, I became a professor at Northeastern University, like I said, jointly appointed in electrical and computer engineering and communication sciences and disorders. And I've been there for the last couple of years. So
That's awesome.
that was my journey. It was a long story, and I'm sorry you have to edit that down.
That's all right. No, that's okay. We probably won't edit much, but
I apologize then to your audience for the
no.
long history. Uh,
Yeah,
it's nonlinear.
the example I heard you use on the Phelan-McDermid podcast is if you tried to measure your house in miles,
Yeah.
you know what I mean? It would round to 0, essentially. So they would say, "Well, there's nothing there," and it's like, "Well, there's something there." And furthermore, if the house I'm sitting in right now, if I put on an addition and doubled the size of this
Yep.
house, and then I said, "Look how much bigger my house is," it would still round to 0 if you were measuring it in miles.
That's right. So yeah, if your yardstick is a mile, if you're
Right.
like, and you say let's measure how big your house is, well, yeah, it's not on there. And again, you can make your house significantly bigger,
Mhm.
and it still will not show up if your yardstick is a mile.
Mm.
And so many assessments, and it's not like the fault of these tools that we have. Most of these tools are saying, okay, does your child look at you? Do they coo? Do they yell? Do they fuss? Then do they babble? Then when did they say their first word? Right? We sort of skip from like, okay, do they babble? And then, when did they say their first word? And then like, when did they say 10 words? Right? Like
Mhm.
these are all because then we jump into things like, when did they start combining words? When did they start, doing pragmatic, all these fancy things? Like we go into semantics and we go into pragmatics, and we have so many other developmental questions that we want to ask, because usually this happens in a really condensed time frame.
Right.
But in my population that I work with on a daily basis, that's not the case, right? It
Yeah.
happens on a time frame of years, sometimes decades.
Mhm.
And the really important thing is that these individuals are developing and
Yes.
growing
Right.
and changing over time. And I think that validation is like the baseline of like, can we at least show that? Can I at least show you how they're growing and changing over time? Or at
Mhm.
least listen to your report, listen to you tell me all the ways that your child is growing and changing over time, and validate that? Because I think that we're missing a lot. We're missing a lot of knowledge about the human species when we try to fix it and stuff it into the existing framework that we already have. But changing frameworks is hard and slow. It's
Right.
like it's like rerouting a river, it's like
Mhm.
one shovel scoop at a time.
Yeah. So, yeah, well, let's get into it then. Tell our audience about ROSCO, exactly what it is and what you're trying to do.
Yeah, so ROSCO is one of a couple of different studies that I'm running. It stands for Rapid Online Sample of Communication. And the idea behind it is to get what we typically call a natural language sample. So a natural language sample could be something like this. You and I have a conversation. and we chat, and then I go ahead and I analyze how many different words did he use. It's called mean length of utterance, like how long did I talk before I paused, and how many different words, and what was my prosody that they changed, my pitch and my tone. Can I measure my vocal quality? You could ask all sorts of questions with a natural language sample, and we can do it for verbal speech like this. We can also do it for like toddlers in a room where you say, "Hey, look, there's a little doggy. Let's play with the doggy. Oh, give the doggy a bath." Like, "Oh, good doggy," right? And we sort of elicit like, "Oh, they say doggy and bath and bubbles," and right, there's sort of sharing in this conversational process. And spoiler alert, like this is not an infrastructure that works for most of our kids, right? Most of MEF2C, but also so many other individuals in this population. So I often start my public talks, my science talks with a graph that says, hey, look, I work under this umbrella of complex neurodevelopmental disorders or differences. And that includes some, but not all individuals with autism spectrum disorders, many individuals with intellectual disabilities, many who have genetic, disorders or genetic underpinnings, as well as other neurological conditions like epilepsy and cerebral palsy. And then within that, I work on the population that has, zero to a few spoken words or very minimal speech over the course of their lifetime. And even that subset of all these different things is over, my best guess, it's certainly underestimated or poorly estimated, is at least 1 million individuals in the United States alone fall into that category. Okay, so it's not just like these few people, it's this entire swath of society, of
Mhm.
the human race that we're missing. And we don't have a way of looking at it. So I sort of, stand on the shoulders of giants, of people who have built these natural language samples for toddlers and even some, early development in infants and toddlers, and tried to translate it into something that would work across these complex neurodevelopmental differences, and do it then also in a way that's more accessible and hopefully allows us to get bigger numbers, sample sizes, and is more strength based, really based on the ways that individuals are communicating. And also, really importantly, captures the knowledge that caregivers and parents have of the ways that their child is communicating. And by child, I mean adult children too, right? So
Mhm.
just like people, the important communicator in your life, who uses their unique way of sharing their communication with the world. So ROSCO is fully remote. It's done entirely over Zoom. We ship smartphones and tripods to families, and we have them kind of set up so that we capture all the angles in one take. We do a lot of prep with the parents to pick out parts of the activities. So we've set it up so it's highly personalizable, but also generalizable across individuals. And that's important scientifically so that we're kind of looking at the same thing or the same structure of things across individuals. But I want to make it personalizable so that it's not like you have to play with the doggy
Mm.
and give it a bath, right? We can play with your toy that that you love, and that is the way that you communicate in a day-to-day experience, right? So we do a snack time, we do a free play, we do a bubble blowing activity, which is a little more structured. Actually has a communication temptation in there where you kind of pause and stop blowing bubbles to allow for the spontaneous communication. I'm like, hey, what's going on? Or like, more bubbles, please.
Right.
And we also do a similar thing with video. As we know, this is often a real world experience where the video buffers in real time. It looks, and we actually take your favorite video, your child's favorite video that you send us, and we make it look like it's buffering, even though it's actually not, so that we can elicit and replicate that real world experience. And because we have the cameras in multiple angles, we get this all in 15 minutes and we get it all in one take. And so far, we've been 100% successful at doing it for all of our individuals in our studies. And we've had really high, like almost 99% of our data that we get, we can code, which means we didn't lose them. They didn't go off camera. We were able to like get their vocalizations and their facial expressions and their gestures and the way they're using their body and the way they're using their AAC devices and other ways of communicating. It's the ways that they communicate during their daily life. And then we have an entire second component that is the parent or caregiver or the person who knows that individual really well, rewatching that 15-minute session with us. And so the child's free to go. They only have to be there for that 15 minutes, which is really important. Again, built around the time and energy that families have, and really respecting the needs of the kids. But we rewatch that 15 minutes, and this has taken a couple of years to develop, but we want to turn caregivers into communication scientists in about 5 minutes, right? We want to give you the tools and the structure for you to be able to tell us reliably and consistently across parents and over time how your child is communicating. So we actually pause the video every 10 seconds and we ask, did you observe any communication or did your child communicate with you, do anything to communicate with you or to send a message to you during that time? And then we kind of walk through what that is and what it was and what it meant. And that allows us to look at the data from two different perspectives. From the traditional perspective of like, we can just code these 15 minutes. And by code, I mean, we label it, we go through and we say, I see that they're pointing for something or they're asking for something or, they're trying to get you to stop or to start doing things or they're making a comment, with their eyes and their hands. And we can do this using a traditional infrastructure without parent influence, without parent insight and guidance. And we can also look at it with all of this knowledge that the people who live with these individuals every day have and, hopefully see what's similar. Like some things I think are going to overlap really well and some things may be different. What's reliable, how can we change it and adapt it so that parents feel good and empowered to share this knowledge, but also are giving us consistent information that we can show to other people and they're going to say, yeah, like this is a great way. And we kind of fully trust, right? This is a really different way of pursuing scientific information. So we have to build it in a way that fits the infrastructure of how science is built, which is this reproducibility aspect. And that's hard when you're trying to, again, help caregivers or help parents become communication scientists very quickly. So that's ROSCO. And then we can also look at it across other developmental assessments and see where it fits, see what new things it's telling us, what things are consistent with the tools that we already have. And hopefully allow for some more sensitivity in the way that we're tracking these things so that if your house gets twice as big, we can see that difference and we can celebrate that difference.
So how does like everything you're talking about with data collection makes sense to me. How are you actually like quantifying that and like if you were going to take the system you're developing with Roscoe and sort of create a standardized assessment out of it, like what would that actually look? I'm just struggling with how you're taking what you're doing and translating it into sort of a system that most people can wrap their heads around.
Yeah, so it's a process, right? And I will say we're pretty far from being able to tell you what that measure or what we call
Mm.
a metric, right? Like what that single number is that really is the strong thing that indicates change over time. Remember the example I gave you before is this mean length of utterance. So like how long you talk, how long your sentences are, the number of different words you use, the number of conversational turns, right? Now it's weird here because you're interviewing me, but like sometimes
Mm.
when in natural language sample we're saying like how much do you back and forth
Mm.
chat, right?
Mm.
And how does that? So those are some of the measures or metrics that we have. Not all of them translate, as you can tell, into what we're doing in Roscoe and what we're looking at in this community, which means we have to go find it. So it may be the frequency of communication, how much are you communicating per minute in any form with your hands, with your eyes, with your body, with your mouth, the sounds again,
Mm.
like that's often communication, not always, and that's why that parent input is often really helpful. So it might be that. Yeah, that's one of the ones we're really actively looking. It might be the type of communication that you're using. So lots of kids are asking for things, right? Do you want the banana or the apple, or the applesauce pouch or something? And they point and they ask, and they're good at that. But they're not. The next level would be like commenting. Did you see the dog? I saw the dog. Like, oh, look over there at that book. It's a cool book. Or I
Mm.
think your shirt is really nice today, right? And not in those words, right? Again, we recognize that it's not going to come out in a sentence like that, but it might be like, like tap, tap, I see this new pin you have on. I'm not asking for the pin. It's not a sensory thing for the pin. It's like, I really like this pin, right? And that kind of commenting behavior tends to be a little bit more developmentally advanced. It tends to progress a little bit, usually in typical development, after some of this what's called regulatory behavior, this asking for things or telling you I want something and I don't want something. Um, and same thing we have other types of things of social interactions. There's things like social niceties, like I say please, or I say thank you, or I greet you, hello, and you say hello back, right? Or
Mm.
we have this kind of shared affection where like you smile and I laugh and I smile and I laugh.
Right.
And that's like an acknowledgement of this shared exchange. So we may find that the things that are really changing are the types of communication and how it's being used. Another option, right? And we're looking at all of these, right?
Mhm.
So we're looking for things, what's stable, what changes over time. We're kind of taking broad strokes on like across population, like you talked about, like we have different ages or we have different, here they are developmentally on other assessments. Where are they in ROSCO on these different domains? We're also looking longitudinally within people
Mhm.
and saying, okay, can we find these things that are changing over time? And we interview parents and we look at it, try to look at it really holistically. So we also might find it in the ways that they communicate. Are they using their AAC device more? Are they using vocalizations a lot more or gestures? Are they moving from gestures that are really about like hand leading, like me using you as a tool to get the thing that I want, versus like more what canonical or more traditional conventional gestures, like I'm pointing to this thing across the room or I'm pointing to the water that I want, that's at the table. So those might be the changes that we see, but you can tell how subtle they are, right? Like these are little samples of things that typically would all be grouped under one umbrella, or maybe wouldn't, we wouldn't really be parsing them out as like a knob that might be, or a variable that might be really important to look at. It went from 5 to 10 over 6 months
Mhm.
because we group it all together. That's an does that make sense? Like it
Yes.
sounded like it was okay. I want to emphasize though that this is a process. Like this
Right.
is not established and this is how much goes into creating a new thing, right? Right.
Mhm.
Right now, Roscoe exists as like a protocol. Like we've mostly standardized the way that we ask the questions and the way that we run the study. And that took 2 years. And now we're working on continuing that, right? To get more data and look at these longitudinal things, look at something called test retest reliability. So if we do it close to one another, a week apart, we expect measurements to be about the same. But if we do it 6 months apart, we expect them to be different, right? We hope that there's some change that we can observe because that's that sensitivity that we're looking for. But then if we look at 6 months, 1 week apart, right, then we can say these should be the same, these should be the same, and this should be different. Sorry, I'm using my hands. And
That's all right.
I
You're
know
okay.
it's a podcast, but 1 and 2 should be the same if they're about a week or two apart. 3 and 4 should be the same if they're about a week or two apart. But the difference between the 1s and 2s and the 3s and 4s at 6 months apart should tell us something about the developmental change over
Right.
time.
Yeah. And also through the process of Roscoe, other well, yeah, other questions will definitely come up that are very interesting and people will chase those leads. And I think sometimes it's confusing because like a lot of people's understanding of science is like the scientific method they learned in the 5th grade or something. And oftentimes that starts with like asking a question. And the thing is you can't ask questions if you don't have any information to begin with. If that
Yeah.
makes sense, you know what I mean? So the more by gathering information through Roscoe, you'll be able to ask more meaningful questions that you can then pursue.
Yeah, it's interesting that you bring it up. And I actually Googled it to double check. The first step of the scientific method is observation,
Mhm.
right? And
Yeah.
that comes before questioning. And it
Right.
comes
Right.
before, those both come before.
Mhm.
And so that's where we are, right? So we are in at least that's where we've been for a while, is in this like observation. What do we
Mhm.
get? How do we get it? Is it working? Can we get these set up? Like, are people comfortable? Are they making it through the protocol? How do we change the instructions and the
Beautiful.
directions? So much work goes into the creation of each little part, right?
Mhm.
The way that we introduce the 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 study matters, the way that we ask the question. So we used to ask for, show us your child's, we want to capture their best communication, right? The optimal expression of their communication. And what that did is that turned parents into therapists. And they would sit on the other side of the table
Mm,
and they'd
mhm.
say, okay, let me show you all the things that they can do.
Right.
And that's totally valid. It's true that that's probably a more optimal expression of their like, these are all the things they can do. Almost like a dog and pony show, though. Like it was one very performative. Like,
Yeah.
these are all the things they can do if I set it up and here's the environment. And we realized that that's not the most meaningful measure,
Right.
right? It's what they're using. How are they communicating in their daily life?
Mhm.
And that's very hard to actually get a raw sample of, right? And anytime we observe something, we change it. We know
Right.
this, like
Yep.
there's physics
Mhm.
again, right? Like we know that there's some effect here. How do I set it up in such a way that that change is at least as minimal as possible?
Mhm.
How do I get you to feel comfortable saying, like, inviting me into your home, at least via Zoom? And also like during the actual thing, I am off camera, I'm off mic. Like this is an interaction between the two of you.
Mhm.
So we like have to prep you beforehand. We keep time. So we're kind of like a fly on the wall and we're recording it, but it's not meant to be between you and me or your child and me on Zoom because that's not natural, right? Like
Mhm.
that's not going to give us what we need. So how do we build all these things so that our observations actually match the questions that we want to ask? And then we can start to get like your question on like, what's the measure? What's the thing at the end, the metric that tells
Mhm.
us the information? That's like we're creating these hypotheses like, well, I think it might be frequency of communication, or I think it might be type of communication and how it's used, or, how it progresses in this particular activity. Those are our hypotheses that now we're testing. And then to get really good, we need to do it again with that hypothesis already established
Mhm.
and say, okay, we're going to test this and we think these two things are going to go together. Or we're going to see this change over time. And then we see it, okay, that's a good thing, right?
Mhm.
That gives us a lot more credibility. We're at least 6 months away from that though, I promise. Like we are that one's really hard because you have to know exactly what you want to measure and like look at to do this to do rigorous hypothesis testing. Anytime you hear a p-value or something like that, it really is meant to have an a priori before you begin hypothesis and then you test and look at it, which isn't always how it's done, but
Mhm.
that's how it's supposed to be done. So yeah, we are using the scientific method here, but it's really focused on spending a little bit longer understanding the population and having a conversation with the population and making sure they're part of this creation, which I'm not the only researcher doing this. There are many, many people out there who are taking this approach and really trying hard to kind of find that intersection with the families and the individuals themselves and give them the voice.
Yeah. Switching gears a little bit here, how do you think sort of new emerging technologies, things like doesn't necessarily have to be these things, but just like sort of the hot things would be like AI, machine learning, brain computer interface if you want to get really crazy. Like what is your opinion of these things as it pertains to MCHS and similar disorders?
Yeah, yeah. So I think it's very exciting, right? I think there's a lot of opportunities that we can leverage from the abilities that we have with AI, with large language models. So again, Roscoe is only one part of what I do. And
Mhm.
part of the reason that I created Roscoe was so that I could get the data. Like, yes, I want to understand communication. I want to interface with these families, but to even do some of these exciting things like you're talking about with technology, we need data from this population. We
Mhm.
need their sounds, we need their movements and their gestures and the way that they're interacting so that we can augment it, right? So that we can facilitate better conversational turns, so that we can build just in time and real time augmentative, AAC, augmentative and alternative communication technology that's like aware of their context and aware of their environment or, aware of the ways that they're already communicating. So this is definitely an avenue that we're trying to take. It's ambitious and we're very much at the early stages of finding things that work. But my lab does a lot of machine learning. We do a lot of looking at ways that we can intersect or leverage the tools and technology that is being developed for maybe mainstream, and how do we also then build our own technology? So we build our own devices and sensors and sensor environments and things like that. We use wearable sensors, we use a lot of other things to really again try to take this complete picture, because when we build these other technologies, also then we get data from them, and that
Mhm.
data can tell us about the development. And then we try to go full circle. So I often put these three Venn diagrams of like the science, right? I'm really interested in these fundamental questions of human nature. How are we growing? How are we developing, especially for this population? To answer that, we have to get the data. To get the
Mhm.
data, we often need to leverage or use, like build new technology or new techniques like machine learning, signal processing, new devices, new sensors, etc. And then the only reason this works at all or matters is the people, right? And so we try to say, okay, what are the types of knowledge? What's the scientific information that these families are asking for? Also, what is the type of technology that could be life changing? Same thing with knowledge. What could change their lives or help them in the greatest possible way? And then my research questions in my lab are defined at the intersection of those three things, right? If we answer any one thing, then we'll be able to hopefully advance these three domains: the science, the engineering, and the human impact. So Roscoe's a good example of that. Like, not only do we get these kind of communication measures, but we also get data. We get
Mhm.
video samples and clips, and like we just got a paper accepted, which in academics is like woohoo,
Mhm.
our big excitement on like using ROSCO data to understand how individuals were using their bodies for different types of communication acts. And again, this is a quantifiable thing. You can build it with a network. You have different nodes for their head and their arms, and we were able to track it both at the population level and the individual level for different types of communication acts, these requests and rejecting behavior, which is that first step of saying, okay, could we build an interactive augmentative technology that is aware of these differences and able to track them over time, either to augment that communication or to developmentally understand it from a science perspective. So it's a process, though, and each step is kind of has to be mindfully done with this entire infrastructure in mind. Otherwise, it's you get to the end and you realize your data's not usable. Or like it's not, the machine learning model that you thought would work does not at all, which we've
Mm.
done many times. Yeah, so it's definitely on our mind and we're really
Uh,
excited about it, but it's going to be a process.
are there any other, maybe you can or can't talk about this, any other like more practical examples of that intersection?
What do you mean?
Like, I don't know, and this is just me imagining, I don't know anything about AI or machine learning, very little, but like I could imagine like AI being able to pick up on subtle differences between vocalizations that our children might, or we might not be able to pick up on with our children, and then like maybe very roughly translating their vocalizations into something more understandable for us. Things like have you made it that far yet into like having ideas of things that you could do that like could impact a family's daily life? Does that make sense?
Absolutely, but I think I would encourage you to reframe your role in that technology. So one of the other studies that I run is called Evoca, and we actually look at vocalizations and we record
Mhm.
them over time in real world using a smartphone app that we developed that captures these vocalizations, like these sounds, but the meaning, the understanding, the function of it comes from the caregiver. So you're the one who says, "I know that that's a frustrated sound." I know that that's a request sound, and in part you have the context. Like I know it's a request sound because you're like
Right.
handing me a banana. Ah, ma,
Yeah.
ma, ma,
Right.
like open this for me. Or I know
Mhm.
it's a delight sound because like your favorite music just came on and we're like jamming out.
Mhm.
And so you have all of that context. And one of the questions that I had early on, and this was with actually started during my PhD with a collaborator of mine named Jared Narain. We were interested in like, well, if you could give us that information with the context, with all of
Right.
that confidence, what you had, could then our machine learning models that we could build use just the audio? Can we find separable differences
Yeah,
that
that's
a
what
machine? So
sort of what I
yes,
was imagining, yeah.
the answer is yes. It exists and it's there, and it's in my dissertation.
Gotcha.
And so the question now for me is that how far can we take that? What's universal across individuals, right? What's a sound that a lot of people make that is something that's really similar across individuals? And what are things that are different across individuals? In some ways, you're kind of think about it as like we get to discover the language. And this is, again, Evoca, which is this other study, exploration of vocalizations, EVOCA, is this exploration of like, let's take these vocalizations and understand them as a new language, right? As a way that we communicate between individuals and track this communication over time. Let's look at it within individual and across individual and find what's really similar, maybe even universal. Like maybe everybody has these core components. Like one of the hypotheses that I have and have seen is like frustration is this really primal fundamental sound that is often expressed and often well understood and does seem to have a lot of similar. So it's like often an open vowel sound, right?
Mhm.
Like these open vowel sounds that doesn't have a lot of syllabic content. So I'm like
Mhm.
babbling or like consonant vowel pairs. And so, but not always. Like, but most of the time we see this. And the question is kind of, do we see this? The hypothesis that we have is like, do we see this similarity more so across individuals than we do if you look like within their different vocalizations within an individual? So like requesting sounds. So like Felix, who has no spoken words ever. He's 14. He has never said a word in his entire life. He often, I'm when he that like I know his sound. I know his like
Mhm.
like his frustrated version of that sound as well. Like you are not listening. I am telling you something. Like
Yeah.
come on, like I need this thing or fix it faster. And as he's gotten older, that's changed, right? That's evolved in the ways that he uses his communication, the way that he communicates with us versus others. all these rich, exciting questions that we can ask. And we're in the middle of it, right? So
Mhm.
I wish I could tell you the conclusion, the answer, but I know that there's a rich signal there. And
Mhm.
I know that it can be understood and viewed scientifically, right? So how
Mhm.
do we view it and track it over time? I also think that hopefully it can be useful, maybe not for the parents, right? I view you as the ground truth, right? You know your child better than anyone on the planet. I'm not going to tell you something new about your kid, except maybe how they relate to other kids and, like insight that we can glean there. But it might be really useful for like new people in your life,
Yes.
right? Grandparents, new
Right.
caregivers who are coming to your, new teachers who you're meeting for the first time where they don't know your kid. Also, so many people on the planet are waiting for words. They're
Yes.
waiting for your
Right.
child to talk.
Mhm.
And in fact, in science, there's so many things that like we can start asking these questions once they have 5 words, right? Or once they can say these sounds consistently, then we can start asking these other interesting things. Well, what before then, right? Like what are we waiting for? I'm going to wait my entire existence to be able to ask those, at least for my kid, right?
Right.
So what can we ask right now? And
Mhm.
I think that's a really important um thing to showcase is that these sounds have meaning. They have consistent meaning and different meanings, right? So
Mhm.
like there are sounds that mean there's a sound
Right.
over time, and that is different than the sound or the sound or the sound that we hear, and sharing that with someone else is like could potentially, and this is something we've tested anecdotally but not quantitatively, we're working on it, is something that could change their perception and the ways that they respond to that individual just by realizing that they're communicating and that these
Yes.
sounds have meaning.
Yeah.
So
Well,
yeah.
yeah, like my friend Andrew, we talk about him every episode, but he's a speller. And the first time I met him, he had to gently but firmly correct me because he would spell something to me, his mom would tell me, and then I would speak back to Susan instead of speaking
Mhm.
back to Andrew. And at one point I was in the middle of the sentence and he grabbed her hand and bop, 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 and he said, "Don't talk to her, talk to me." And I was like, "Oh,
Yeah.
you got it." So I could see things like that giving I'm struggling with I guess, an independence to those
Yeah.
people, because like, you know, Felix is 14, he doesn't want to have to tell he doesn't wanna have his mommy have to tell everybody everything for him, you know what I mean? So,
Yeah, I think the word you're looking for is agency. So
yes.
it's empowering these
Uh-huh.
people to feel like they can communicate and be understood, and
Right.
that's really important. That is fundamental to the way that we communicate and the way that we learn to communicate as a species. I say something to you,
Uh-huh.
you respond because you understand. I am then encouraged to say more things to you.
Uh-huh.
Right? I am empowered. I recognize that my communication has power, right? It can change things and it evolves from then, from there to new things, to new ways of communicating, to feeling like you can communicate with other people, with strangers, with new people in your life, with friends. You can share new things. And now, do I think that this is a panacea? Is it going to solve everything? No, it's a step though in
Uh-huh.
that direction of at least acknowledging the ways that these individuals are already communicating, the richness, the expressiveness that they are sharing themselves, and empowering other people to join them in their language and the way that they're already sharing information with the world.
Right. Absolutely. Yeah. Um,
Uh,
so how can our community either directly or indirectly through funding support, whatever, help you with your projects?
yeah, I'm going to talk about this more broadly than just me, because I think a lot of the things that I experience is consistent with a lot of clinicians and a lot of researchers in this space. I meet with lots of parent groups. I talk at conferences and get the privilege of working with their kids in my studies and things like that, and or with the families in general in my studies. I think being organized is a really valuable perspective. Having people who are really excited and willing to engage in the research, which we have, I
Mhm.
think that's wonderful. I think feeling a sense of like, let me see. Yeah. So,
Mhm.
okay, let me put it this way. So when researchers are looking for groups do you know the phrase PAG?
I don't.
So it's like patient advocacy group, parent advocacy group, things like
Gotcha.
that. They're often an overarching term for kind of these types of things, right?
Right.
Everybody comes up with their own name, the Family Foundation, this thing.
Mhm.
all the different groups that we have, but they're often broadly listed under PAGs. When researchers are looking for PAGs to partner with, they're looking at the same things that you would do for any like employee, or any collaborator, any friend in your life where you're like, are these people good to work with, right?
Mm,
Are they good at responding to emails? Do they feel like they're a united front, right? They have kind of a cohesiveness in the community where we feel like if we start a study with them, we're going to be able to recruit the numbers that we need. We're going to be able to work across their databases, their doctors, all these different things, because it's a lot of work. It's an insane amount. And we've seen this with the studies that have started with MEF2C, that it's just like it's a really intensive level of effort that everyone has to go into, including the families. And so I do think just being really mindful of like collaboration and resource sharing and things like that is really helpful. And it's something that organizations like, again, researchers, doctors, clinicians, depending on there's a lot of research that comes out of like hospitals, research hospitals, but there's also some that comes out of like universities where I am now. They're looking for good people to work with. Does that make sense?
mm, yeah.
So I think that's an important thing, and I think you're doing it. I think the Family Foundation especially is a really special front for that. So in Phelan-McDermott syndrome, where I have just one example of a genetic disorder group that I have a grant from, right? So they're much further. They've been around a lot longer. They're much more. They have a larger population, and they have a grant call every year, every couple of years. They started it a few years back, so not even in their infancy. But one of the great things about getting it's a relatively small grant, but it's powerful in the connection that I get to have with the community, right? I get to interface with them directly, and they are writing to me and saying, hey, can we participate in your study? And that's a big deal because recruitment and interaction is an enormous amount of time on our end. It's an enormous amount of time on your end, but it's also an enormous amount of time and money and resources and infrastructure on our end. And so people are really excited to work with like good people, which makes sense. This
Right.
isn't like ground earth shattering.
Mm.
But I think that is the number one factor is are you organized? Are you, good to work with? Do we have like the database that we have, these trials that we're getting started where we're looking at data, as long as they're built in such a way that we can really share the data is very important so that we can kind of advance the field. And I think, yeah, I think, camaraderie
Are
is really
you
important.
are you looking for what was the app you said you had?
Yeah, so it's a custom app right now that's not available
Okay, gotcha.
on the App Store as part of my Evoca study. It was
Right,
formerly
Evoca.
the study that I ran in grad school was called Kamala,
Gotcha.
Commalla, which is there's a little bit more information online about that than there is
So,
about Evoca.
are you actively looking for participants in any of these studies? And then
I
how
am.
can people get involved that way?
Fantastic question. Love that question. So, yeah, Evoca is actively recruiting right now. It's a longitudinal 2-year study where we are capturing vocalizations using our smartphone app in the wild, in your homes, in daily lives. So, these sounds that your child is using to communicate, you label them on the app, and then you share those vocalizations with us. So, by label, I mean you say this is their frustrated sound and this is their
Mhm.
request sound, like when you capture it in real life. And we have a whole protocol for this. So Evoca is recruiting. If you are interested in being part of the Evoca study, you can email my lab at nddlab, that's LAB. And that's like neurodevelopmental dynamics is the name of my lab. So really changing our emphasis on the ways that, the disorder, the differences, and really focusing on the trajectories, on the ways that they're growing and changing over time. Neurodevelopmental Dynamics Labs, or NDD Lab, at Northeastern, I think you can spell that, .edu. And my research team will get in touch with you if you're interested. ROSCO is not actively recruiting outside of our current funded study. So this is a good example for the community to be aware of. So Evoca, I built in such a way that I got funding for it agnostic, or, not attached to a specific genetic disorder or diagnosis of any kind. But ROSCO right now has been funded so actively by different groups that I actually don't have the bandwidth. I don't have the personnel to recruit outside the currently funded studies that we have. So we're running ROSCO a lot, but it's actually being done through different neurodevelopmental disorder groups already, and other studies that exist right now. So that's really exciting and that's really fun for us. But that's a good example of like having an organized genetic foundation and family foundation like you have can help facilitate that, right? Where you bring in researchers to work for you to ask the questions. Like if you wanted Roscoe done, that's a way of saying, okay, either we raise some money or we build some money to bring this researcher in and say they're really going to focus on us. Again, we try. I would love to be able to just like actively bring people in and recruit as much as we can. And if people are super passionate about it, they can reach out. Sometimes we do training protocols, or sometimes we do like extra sessions with people outside of our typical recruitment populations, so that we can train new personnel or test out a new way of giving the information, or doing the surveys or something like that. So you can let me know if you're interested. But that is one of those synergies that the collaboration that you have between a family foundation or an organization and the researcher is that you can sometimes point their head, right? You can direct the ways that they're looking or direct the ways that they're spending their time by forming these collaborations.
Gotcha. Awesome. We'll link or put the email in the description for everybody so that they
Awesome.
can get a hold of you. So we need to have you back on for another episode at some point to actually talk about your personal experience because we kind of got off the rails on that.
I talked to Caroline before this, and she was like, "Oh, they have enough parents to talk about your career and things like that." But I am happy to. I'm
Yes.
happy to share.
Yeah. So what do you think is the hardest part about Felix's mom, and what do you think is the best part about Felix being Felix's mom, or like the way you've grown the most as being Felix's mom?
Those were a lot of different questions. Okay, I'm gonna answer these a little bit differently, maybe than expected. So I have two kids, right? I have Felix and I have Vela, and they're
Right.
both incredible, and they're both different,
Hmm.
and they're both challenging in their own ways, right? I actually don't think there's anything in particular about Felix that himself that is more difficult, or the hardest thing or something like that than just the challenge of being a parent in 2025 and being a working mom, and having a both of us work, and wanting the best for my kids. Like, to me, so much of what I experience is just the challenge, the slog some days of parenting. I wish that there were changes in society
Yeah.
that better acknowledged his existence, right? This is kind of what I was saying at the very beginning of like, well, there's lots of things for 2-year-olds and little music classes where they're allowed to run around and make all the noise they want and like throw things and lick things and whatever because it's expected for two. But the chairs are tiny. They're like,
Hmm.
it's a tiny little space in a room for my 14-year-old because he's amazing and he loves music and he would love to go do that with a bunch of other kids. And there are so few of those opportunities. Now, he's an amazing program. His school is incredible. There's bunch of Felixes and Felix like, kiddos in his class, and he's getting big and finding ways of making it work, and the teachers are just phenomenal at seeing him for who he is. But I wish more people could. I
Hmm.
wish more people could just see him for who he was, and I wish there was an infrastructure that like acknowledged his existence. I wish that's what I want.
Yeah.
Like, I think that would then make a lot of the parenting challenges that I have right now a lot easier. Like, childcare is like, I run a side business basically to staff enough. Even just like he goes to school during the day, but after school time, because I work a full-time job
Hmm.
and then some, is so intense, right?
Right.
And my career has taken a non-linear trajectory because of like the needs that I have had to have to be with him. And that's not his fault. I don't even see it as his difficulty. I see it
No.
as
Yeah.
like just a lack of it. Like, we had to invent it. We had to create
Hmm.
it for ourselves on how to do this. And that was tiring.
Hmm.
I mean, sleep was a big thing for us, and
Hmm.
continues to be a big thing. It's changing a little bit in puberty where he's like sleeping in a little bit more, and I'm really excited about this. Very, very excited. But we won't talk about the time my husband punched a hole in the wall because we were just so tired.
Yeah.
Like,
No.
the sleep deprivation is real. This is how you torture people.
Hmm.
I mean, it's like
Hmm.
insane. And like, I don't know, having and going to a MIT grad school and trying to like learn a whole new career and develop a whole new discipline. Like, as I was had a special, it was insane. It was crazy. Like,
Yeah.
it's been hard,
Mhm.
but like, I don't. those are some of the choices that I made, right? I also make things hard. I'm pretty intense. Like I pursue paths that they don't have a clear direction in front
Right,
of
yeah.
them. That's so it goes hand in hand. I can't necessarily disentangle and say like this is Felix and this is the other thing.
Mhm.
If you pin me to the wall, I would probably say sleep because that is like, whew,
Yeah.
tough.
Mhm.
But again, like my daughter has her own needs and her own life and her own things that make our lives complicated and increase all these, chaotic processes, these little pendulums that we have swinging in every different direction. And I think it's at least for me, and I don't say this flippantly. I'm not trying to dismiss it, but it's been much easier. My coping mechanism has been to just say, like, life is hard. Life is
Mhm.
hard for a lot of people.
Mhm.
And in many ways that I don't know about. Right. And realizing that, and also realizing that hardness is relative. Your hardest thing is your hardest thing.
Mhm.
I don't care what it is, right? If you're in college and your hardest thing is your final exams or that you have to like carry all your laundry to the laundromat 3 blocks away, like what, that's your hardest thing. Like, and it scales. And so we have new hardest things that are different than other people's hardest things, but like we just kind of stretch and morph to fit those as a family. And again, I don't say that flippantly. We have no
Right.
family nearby. Like I've radically changed my career. It's at a totally different timeline. There have been days and weeks. I almost dropped out of grad school 3 different times because I was like, I can't do this. There's no I not only can I not do it, I've never seen anybody do it.
Mhm.
Like it can't be done, like on those dark nights where I'm like so sleep deprived, I can't see straight or like whatever.
Mhm.
We won't get into those dark times, okay? I really wasn't sure. And I was lucky to have one or two special people in my life who were like, "Christy, you're already doing it." You know?
Mhm.
Like just keep going. Like what can we do to help? And they often weren't the people I expected. They weren't it wasn't because I had, this vast network of, people to draw from. It was just semi-strangers or people who came to my aid and helped us out and got us through and got us over that hump and said you could do it and we did and then we realized that we could.
Mhm. Yeah.
And that, like, is really cool. It's also really special, and, maybe it's to credit to Felix, to, like, teaching us that we could just, like, be different than we totally expected, and I've realized that life is still beautiful and incredible and awe-inspiring, and we're just like, humans are amazing.
Mhm.
Wow! Like, look at the spectrum of human, like, that we can get on this earth.
Mhm.
It makes me in awe of all these different things. And I will also say, like, again, I present this knowing that there are a lot of times where I don't even have the energy to feel awe. And I am so tired and I am sad and I am confused and I am not sure which way to go. I don't feel like this all the time. But I also, like, I felt like it enough, that I can now start to remind myself. And I'm lucky to have other people in my life and lots of post it notes around my room have these things written down to just like remember to reframe it in that way. And to me, it's been really helpful. I don't know that it would be helpful for everybody. I don't know it's where everybody is in their life. I go through many periods of grieving and mourning the life that I thought I would have,
Mhm.
which is normal and healthy and important. Like you have to, it's okay. It's okay to do that. But I also am really, really grateful and excited for the life that we have right now and, the one that's going to be tomorrow. And that's really cool.
Mhm.
And again, like it's okay. And I really think it's important for people to hear that, like, if you're not here on this journey, if you're not where I'm talking about, that's okay. You don't have to be, you don't ever have to be. It's not the best place. It's not the place. There's not only one place. This
Mhm.
is a place though that we have gotten to as a family. And I would not change my family. Like I think they're incredible and I would like to change the world, but I'm, really, really lucky to
Right.
be Felix and Bayla's mom.
Yeah. Yeah, the one of the things we've been talking about a lot on the last few episodes is the fact that, um, like, this is an adventure,
Yeah.
and,
A roller coaster?
we have sort of a very simplified, like, child storybook idea of what adventures are, but, like, in mythology and things, like, normally first of all, normally the hero of the adventure doesn't actually want to go on the adventure to
Yeah.
begin with, And normally it's really hard. It's not like this fun, they don't feel like the hero the whole time. They end up the hero in the end, but it's sort of given to them, and what you can do is embrace it. Which, Leo's going to be 3 next month, so we're still just starting out in this. So I understand that, any advice that I give can only be given so much weight. But the other thing is, like, I used to be into long distance running. Now I do strongman stuff, so I pick up heavy things. But like a significant part of both those things, like there are actual muscular, cardiovascular, whatever adaptations. A very significant part of those things, though, is like running 20 miles and realize you won't die if you run 20 miles. Or
Yeah.
like picking up this thing where it feels like your eyeballs are going to fly out and then they don't. And then you realize I can do this. And like I think a significant portion of this parenting adventure that we're all on to is just realizing that we're actually capable of these things. And once you do them, then it's kind of like okay, you know what I mean?
Yeah.
Because at least for me, like, and Haley definitely has it harder with the sleep because like when he wakes up in the middle of the night, he just wants her. But
It's awful.
every once in a while you take a step back and you're like holy horse milk, like this is really hard. But like most of the time you're just doing it and you don't really actually pay attention. You just keep your head down and keep going.
Yeah, it's wild. It's
Yeah.
definitely, yeah, I think both Michael and I grew up with very families that were very focused on kind of a fixed mindset, if you will. Like, you're kind of born with these things. You are good at X, you are
Hmm.
smart, or you are capable, or you are athletic, or you are, musical, or you are whatever. You are kind of
Yeah.
a thing. And that was common also in, generationally. That was a way. And, one of the things we've really changed in ourselves, in our life, in our parenting is really focusing on that kind of growth mindset perspective of like, well, you can be like maybe you aren't this right now. Like, let's
Hmm.
see what we can do. How can you grow? How do you change? How do you understand things over time? And I will say, even the assessments, going full circle here, so many of the things that we do in life, so many of the tests that we take, so many of the ways that we are measured and tracked are like based on this kind of fixed concept of like,
Yep.
you are either here or you are not here.
Hmm.
Even the way that we think about these and autism and disorders and things like that is like, here is a diagnostic threshold. You are on this side of it, you're not. It's binary. You are either X or you are Y. And like, that's not how life works. Everything is a distribution. I mean, the quantum mechanics, but like even that's a distribution. Anyhow, everything's like this distribution. Like there's always to do that again. That's me. My
You're right.
alarm telling me the end of the day is nigh. I'm like, I need to go. I need to go because I'm on borrowed time.
Yeah, you're good.
No, it's fine. This is why we do it during working hours. Um, because the only hours I get. Sorry, everything is a distribution, right? And that like our infrastructure that we've put on it, the words that we say, if it's X versus Y, is a human invention. We have
Yes.
decided to categorize these
All
things and put
categories
them
are
in
synthetic.
buckets.
Yep.
Right. That's
Hmm.
right. Like again, your background is perfect for this,
Hmm.
right? And so when you start thinking about things to me in terms of distributions, in terms of statistics, in terms of like a spectrum of anything, of learning, of communication, of growth, of like, intelligence, of all sorts of things, it changes the way you think about it. And at least for me, it's easier to move across that spectrum when I think
Hmm.
about it as continuous, as opposed to like, am I in this bucket or am I in that bucket? And that is a really cool, at least for us, like a really cool way to go about the world
Hmm.
is to see that spectrum and kind of be looking for it and filling in your little graphs in your sorry, I sound a lot like a nerd,
That's all right.
but
No.
filling in all the graphs in your head. Doesn't everybody do that? I do. It's great. So,
Yeah. All
did I
right.
answer your question?
Yes. Okay. So, thank you so much for your time today. One more time, can you give the email where people can reach out?
Yeah, so NDD Lab, Neurodevelopmental Dynamics Lab, NDD Lab at Northeastern, NORTHEASTERN and then my research team will be happy to reach out to you. Please be sure to put like a little bit of information, either MEF2C or your name and that you heard about it on the podcast or something in the email so we know it's not spam. But otherwise, we can reach out to you. And I suspect most of MEF2C individuals will qualify for our EVOCA study. We also compensated for the study. It's like really designed around meeting you where you are. And then again, future studies as they open up, you would be kind of in our list. So it'd
Awesome.
be great to collaborate more with the community.
Cool. Awesome. All right. And for all our listeners, you can contact us at Facebook. You can email us at mef2cast@gmail.com if you have questions, concerns, you want to be a guest. If you want to be a guest, you can also go to our website, mef2cast.com. There's a form you can fill out that'll put you in contact with us. Anybody who wants to come on, we love to talk to them. And then we also have a Shopify store if people want to buy t-shirts. My favorite one says, ask me about my favorite transcription factor on the front. So thank you everybody for your time.
Thank you so much. This is amazing.